welcome back. This is 3.5 trigonometric limits. We're starting to do some practice problems here using our theorems, theorem 3.11 about these trigonometric limits. And number 8 is the limit as x approaches 0 of sine of 5x over 3x. Now I want to clarify real quick, folks, that this is your angle measure, 5x, okay? And what I want to do, I kind of said this previously, I want to turn my denominator into a 5x, okay? I already have an x here, so that's good. But I have a 5 up here. I need to turn this 3 into a 5, okay? So what I want to do, the trick that we use is that we want to multiply the top and the bottom by a number, okay? So the question that I would say is, all right, 3 times what number is going to give me 5, okay? And that's actually going to be the number 5/3, okay? So I'm going to multiply that on the top and the bottom, okay? And as a result, this is what we get, okay? I get the limit as x approaches 0 of 5/3 times sine of 5x all over, and I'm going to do this. I'm going to do 5/3 times 3x over 1, okay? And what happens is, the reason why I multiplied by 5/3 is because the 3 here and the 3 here will divide out, okay? And this leaves us with the limit as x approaches 0 of 5/3 times sine of 5x all over 5x, okay? Now, the thing of it is that I've got the same, my angle measure now, this angle measure matches my denominator. But I've got this 5/3 that I need to deal with. Now, one of the properties of limits is that I can actually pull a constant out. And by constant, I mean a number. If I'm multiplying by a number here, by this function, I can pull that number out front, okay? So I get 5/3 and then times the limit, okay? The limit as x approaches 0 of sine of 5x all over 5x. Now this is the important thing to see here. This is kind of where we need to make sure we know what we're doing. The angle, again, matches my denominator. So because I have this limit, sine of some angle over that same value, that is my angle, then I know that this limit goes to 1, okay, because of this, because of my theorem. So this value is 1, and I'm left with 5/3 times 1, which then just gives me 5/3, and that's my limit value. Okay, if you were to graph this function and do the table method, then you would end up getting 5/3. Okay. All right, let's take a look at another one. Okay, let's take a look at number 10. All right, now this one looks just god-awful. All right, it doesn't look like anything over here. It doesn't look like either of these. Okay, so as a result, we have to manipulate this. We have to rewrite this. Okay. This one's tricky. This one's is very tedious, and it's going to require a lot of steps, okay? But I'm going to rewrite this, okay? I'm going to write this as the limit as x approaches 0 of, and watch what I do here. I'm going to write this as sine of 3x divided by the quantity. Now, I'm going to rewrite tangent. Now, tangent is sine over cosine. So I'm going to rewrite this as sine of 4x divided by cosine of 4x, okay? And this is all one fraction down in my denominator. Now, if I have something divided by a fraction, then that means that I can rewrite this by multiplying by its reciprocal, okay? So I'm going to do this. I'm going to do the limit as x approaches 0 of sine of 3x over 1 times cosine of 4x divided by sine of 4x, okay? Now, what I'm about to do here is a little bit tricky, and this is why, doing these problems with a teacher, someone that knows how to do these, is important. But the reality is that I've got the limit as x approaches 0 of sine of 3x over 1, and I'm going to multiply that by 1 over sine of 4x. Okay, and then I'm going to multiply this by cosine of 4x all over 1. Okay, now I have this piece here, sine of 3x over 1, and I have 1 over sine of 4x here. Okay, now what I want to do is I want to manipulate this. I notice that my angle is 3x here. I want to somehow get a 3x down here. Now similarly, over here I've got sine of 4x. I want to get a 4x up in my numerator so that it matches my limit, okay? So that I can make it look like this, all right? And we'll see what happens as a result. Okay, so what I want to do is I'm going to multiply this whole thing. First of all, I need an x in my denominator and I need an x in my numerator. So I'm going to multiply this by x over x. Okay, now remember I needed a 3 in my denominator, so I'm going to multiply by 3 over 3 because I got to keep it balanced. And then I needed a 4 in my numerator here. So I'm going to multiply this by 4 over 4. Okay, now let's rewrite this. Now because I'm multiplying everything, I can reorder this. So my next step is going to be the limit as x approaches 0 of sine of 3x. Now I have a 3 and an x that I can put under here because I'm multiplying everything. So I'm going to go ahead and do that. So I've got a 3x down here multiplied by, I want to put a 4 and an x up here. So I've got a 4 and an x over sine of 4x. Okay. Now I've got an x already. I've used that one. I've used this one. I've used a 4 up top. I've used a 3 down below. So I'm left with, okay, I've got the cosine of 4x first over 1, but then I've got this 3/4 that's left over. Okay, now that's the important thing. Okay, so now what I've got here now is I've got the same angle as my denominator in this, and I've got the same thing here. Now, even though this is the reciprocal, even though this limit is going to go to 1, okay, this limit would go to 1 over 1, which is still 1. Okay, that's kind of a tricky concept, but for our time purposes, I'm just kind of gonna go with it. If you that's something we can talk about in class, and I can show you how we get that. But needless to say, if I apply this limit, this part goes to 1, and this part goes to 1. Okay, so now as a result, I get this. Let me switch colors. Back to blue. Okay, I'm going to do the limit as x approaches 0. Okay, I've got 1 and then this went to 1. All right, so I've got cosine of 4x over 1 times 3/4. Now I can go ahead and apply this limit. I can just go ahead and plug in 0 into this function, and I get cosine of 4 times 0 over 1 times 3/4. Okay, now if we evaluate this, cosine 4 times 0 is 0, so I get cosine of 0 over 1 times 3/4. And so cosine of 0, guys, that's just 1. So I get 1 over 1 times 3/4, and so my limit value is then 3/4. Okay, there's a lot going on in that problem, guys. Okay, these are not the easiest problems to do. They're doable, okay, but you got to manipulate it. All right, and I'm solely basing this off of this. I'm trying to put this limit and this function into this form of sine x over x. Okay, if I get that, then I can just run with it because that's equal to 1. So I'm going to go ahead and stop this, and I'll do another video here in a bit.